I'm going to show you how to solve the linear programming problem that was set on the mid-semester test. The problem is about two types of aircraft, the Beech 40 and the Antonov 60. The Beech 40 can carry 40 passengers and 30 tons of cargo. The Antonov 60 can carry 60 passengers and 15 tons of cargo. The company is contracted to carry at least 480 passengers and at least 180 tons of cargo every day. Our problem is to work out how we can achieve these targets at the minimum cost. In order to do this, we will draw a graph, and from the graph we will try and obtain a solution. To draw a graph, we must write down some inequations. We're going to let x be the number of Beech 40 aircraft and y be the number of Antonov 60 aircraft. X, which is the number of aircraft, and y, which is the number of Antonov 60s, must be greater than 0. We're going to now look at the limitation or constraint on the number of passengers. The Beech 40 can carry 40 passengers, the Antonov 60 can carry 60 passengers, and we must carry at least 480 passengers every day. With x as the number of Beech 40 and y as the number of Antonov 60, we can write down this inequation. So 40 times the number of Beech 40 plus 60 times the number of Antonov 60 must be greater than or equal to 480. Now we look at the constraint on weight. We must carry at least 180 tons of cargo every day. The Beech 40 can carry 30 tons of cargo, and the Antonov 60 can carry 15 tons of cargo. As before, with x as the number of Beech 40 and y as the number of Antonov 60, we can write down this inequation. 30 times the number of Beech 40 plus 15 times the number of Antonov 60 must be greater than or equal to 180. Now we have calculated the two inequations representing the constraints on number of passengers and weights, we must draw the graphs. In order to draw these graphs of inequations, we must first draw the boundaries. The boundary of the inequation 40x plus 60y is greater than or equal to 480 is in fact 40x plus 60y equals 480. In order to draw this line, we need to work out what the value of x is when y is 0 and what the value of y is when x is 0. When x is 0, y equals 8. When y is 0, x will equal 480 divided by 40, which is 12. Taking the other inequation, 30x plus 15y is greater than or equal to 180. Again, we must draw the boundary 30x plus 15y equals 180. Again, we work out what the value of y is when x equals 0. And we work out what the value of x is when y equals 0. With this information, we can now draw these boundary lines. So on our graph paper, we first mark two axes. And now we must plot, first of all, the point x equals 0, y equals 8. 2, 4, 6, 8. So let's put a point there. 2, 4, 6, 8. And when y equals 0, x equals 12. 2, 4, 6, 8, 10, 12. And then we draw the line connecting these 2 points. So this is the boundary of the inequation 40x plus 60y is greater than or equal to 480. Now we draw the boundary for 30x plus 15y is greater than or equal to 180 by plotting x equals 0, y equals 12. And y equals 0, x equals 6. And again we draw lines to represent this boundary. When we have drawn the 2 boundary lines, we need to shade the region that's not feasible or not required. The region that is required for the inequation 40x plus 60y is greater than or equal to 480 is the region of the graph above the line. So we will shade the region of the graph below the line. And the region for the 30x plus 15y is greater than or equal to 180 is above the boundary line for that inequation. So again we will shade below the line. And so we now have the required region, which is the unshaded area of the graph. So anywhere in this part of the graph here. This means that any point in this region will represent a feasible combination of Antonov 60s and Beech 40s. So for each of these points, or for any of these points, we could work out the cost of flying these 2 aircraft by using the information here, which tells us that it's £500 per journey for a Beech 40 and £600 for an Antonov 60. So to work out the cost for any of these points, we must write down this equation that represents the cost. So x times 500 plus y times 600 will equal the cost. So for example, at this point here, x equals 5, so that's 5 Beech 40s, and y equals 5, which is 5 Antonov 60s. So that would be 5 times 500, 2,500, plus 5 times 600, 3,000, which would be £5,500. However, we need to find the minimum cost. Now generally, the minimum cost is always at one of the vertices of the required region. So the minimum cost will either be at that point, at this point, or at this point. So all we need to do is work out the minimum cost at those 3 points, work out the cost at each of those 3 points, and then take the smallest value as the minimum cost. When we do this, we find that the minimum cost occurs when, at this point here, when there are 3 Beech 40s and 2, 4, 6 Antonov 60s. Putting those values into this equation here, we will have 3 times 500 plus 6 times 600, which will be £5,100.